Okay, we're going to have a look at the mobile phone system, and having a look at that, we're going to, there's the mobile phones, and the two things we're going to look at is just simply look at their simple functions, and also the energy transfers and transformation. And we know that there's a difference between transfer and transformation. Transfer means that the energy form is not in any way changed, and transformed means it goes from one form of energy to another. To do this, we need to have a look at the following sheet. We have this sheet. This is on the website, so I would like you to download it, and we're going to fill it in. I will give a general overview, and then you can take time to fill it in and do your own research. The sheet tries to follow through what is actually happening as you send a mobile phone call from a sender to a receiver. So there's a pathway that we're going to go through. During this pathway, we're going to have a look at some of the systems that are involved in the mobile phone system. So before we go anywhere, we're going to have a look at some of the things that are needed in our system. The first one, of course, is a mobile phone, and mobile phones have come in different forms and varieties. We're now at the smartphone level, but historically they've looked like flip phones. Before that, they were the old-fashioned Nokia bricks, that or the type of brick that we see in old-fashioned movies. They have been getting better and better and more functionality as we go through, and as a result, that our technology needs to update itself so that we can use these on our networks. So, apart from the mobile phone, we also need these things here. We see them around the place. These are the receiving towers and the transmission towers, also known as base stations. And a base station in the city is basically maybe two or three towers, and those towers can, and you are between these towers. Those towers can then use your the signal from the phone to position within that triangle, and this gives you quite an accurate positioning within this area. And once that position is known and you are registered to the network, the phone can then send signals to and from different towers. So the base station is one part of the system. So let's go through here. That's the base station. So these are the base stations, towers, and we need a mobile phone. Now, apart from this, there are also other parts of the system. There are computer feedbacks, making sure that the signals sent between phone and base station are validated and clear and whatever. Those are, if you want to do extra research, then you can look at those different systems on the network. Before we go any further, we also need to look at the terms duplex. Oh, I spelled that wrong, so I'll just undo that. Duplex. The mobile phone system is a full duplex system, and that means that one person can talk to the other person while the other person talks back. The reason this happens is that there are two different signals that are sent out. One is the transmission signal, and a different frequency is used for the reception signal. There are a few different signals that are sent by the mobile phone, but they're outside what I'm going to be talking about. So when we need to create a call, we can get from sender to receiver in a variety of ways. So let's just go firstly through how it actually can work. And we all know this because we've all sent mobile phone systems. We can go voice to phone, phone to tower, tower to tower, and tower to phone, and phone to receiver. That's one possible way. That's if these two towers are in the same position. So if I've got to this tower here, to this tower and off. But that's not most likely going to be the case. These two towers can be quite separated in a city, or they can even be separated on either sides of a country. So there is a second way that the system works. Between this base station and this base station, there is a variety of ways that the signal can be sent. Majority of the way, if they are too far away from each other, is by cabling. And this is like a landline, where it goes from one place to another by either copper wire signals, so it's copper wire cable, which is the common one, the common wire that is used throughout the streets of Sydney, as well as it could be optical fibre, and they're used in Australia, especially between two cities or between areas which are quite distant. Copper transmission is quick and cheap, but there is a slight signal loss, and there is also a slight signal delay. Optical fibres are more expensive, and the transmission is very close to the speed of light, and it has very little loss of signal. So the two options are, well, the most common one, of course, is copper wire and optical for a longer distance. So that's basically how our mobile phone system is set up in Australia, and we are going to have a look at the transformations now. The energy transformation, of course, is over here. The first thing that comes out of our mouth is sound. Sound, as you know, is just basically a form of kinetic energy, as particles are forced to move backwards and forwards. That's air particles are forced to move backwards and forwards. This sound energy, or kinetic energy, is made to interact with the speaker, or microphone, I should say, more than anything else, the microphone of the mobile phone. Now, the microphone of the mobile phone is a speaker in reverse. Now, we've already done speakers. A speaker, as you know, is a simple cone which is attached to a coil of wire, and a coil of wire is then situated around a small magnet. And if we were to place in a signal, a AC signal, into the coil of wire, this makes the cone move up and down, because this little coil of wire here becomes a little electromagnet, a little solenoid, and it interacts with this permanent magnet in here, making this cone move up and down. So that's how we make a speaker. But a microphone is the exact reverse. We make the cone move up and down. This cone moves up and down, and this coil of wire is then placed, because it's placed around a magnet, and we'll just put it north and south there to make this look like a more magnet. And we know that a coil of wire, when it is moved near a wire, will have induced within it an electric current. And this little electric current will be a current which mimics our voice. And this can be then transmitted as an electrical signal. So just to remind ourselves, I'll just reiterate that a microphone is a speaker in reverse. A speaker is normally electrical current creating sound. A microphone is sound creating electrical current. So let's just rub that out. Come on, let's select it. It's not selecting. There we are. So the next thing in our system is that the sound energy creates an electrical signal. Now, this electrical signal is created by the microphone. Now, that electrical signal is very, very minute, very, very small, but the electronics within the mobile phone enable it to be boosted, and then this electrical signal, that's electricity, you're not going to get this confused with the next part. This electrical signal is then created into a radio wave. Now, the radio bands that we are using here, it's radio/microwave. So it's the upper end of the radio band, the lower end of the microwave. Remember, there are no direct cutoffs between what is radio and what is microwaves. So this phone here is basically a high-end radio signal or a low-end microwave transmitter. So we go sound. Sound makes the microphone move. That microphone makes this electrical signal. Then the electronics within the phone create a radio microwave. And this, of course, is an EM wave. Now, if it's direct tower-to-tower transmission, then we have this microwave can go directly to the other tower, and then this reverse process will happen. And that is that we are going to have this will be received as a radio microwave over here. So one tower transmits it, this tower receives it, and then we have the reverse, that the radio or the microwave is created back into an electrical signal. Oops, electrical signal. Once again, simply, let's get this right, signal, by the same electronics that are in the phone, and then this electrical signal will make the speaker this time. We had a microphone up this end, so this part here was the microphone. This one here has a speaker, and this speaker takes our electrical signal. Remember, it's that mimic signal, and that signal mimics our voice or whatever music or whatever we're trying to transmit. And then that makes the speaker, remember, a speaker is simply a cone. I'll make that a bit better, try and get a different colour. Yeah, there's our cone, and remember that cone is attached to a coil of wire. It's not selecting really well. And that coil of wire is over top of a magnet. And this time we're putting the signal into our coil, and that makes the speaker move up and down, and this creates sound waves. So it's an exact reverse process of the way in. So we've got the speaker, and that speaker makes sound. And remember, that sound is simply a kinetic energy. As it is a compression wave, it's just moving air backwards and forwards, and that some air then hits other air and compresses that, and this compression wave then goes into our ear, and inside our ear we have an eardrum, and that compression wave causes the eardrum to send an electrical signal to our brain, which it's very hard on this tablet here to draw. Okay, that's supposed to be our brain. Looks like my brain. Okay, rightio. So let's have a look at the energy transfers and transformations that we've got as we've come along the way. So we have sound. Oops. We have the sound energy over here, which is a form of kinetic energy. That sound kinetic energy is converted by a mobile phone. We need to know what is causing the transform or the transfer. In this case, it's going to be formed into an electrical signal by a microphone. Then this electrical signal is being transformed, once again, by the electronics of the phone into a radio/microwave as an EM wave. This EM wave is just transferred from one point to another as it is broadcast by the radio towers. These are basically base station radio towers. And then the reverse process occurs. We've got the reception of the radio microwave down here, which is then by the electronics of the phone created into an electrical signal. The electronics of the phone, the electrical signal then is used in the speaker of the phone, which creates sound, which is a form of kinetic energy, and that kinetic energy is used to push our eardrum. Our eardrum is then creates an electrical signal, which is then sent to our brain. So that's the basic form of the transfer and transformations that occur in our system. But we do have one small problem, and that's when this tower to this tower get that a different colour. So I've just got forward. When this tower to this tower sends it by either copper wire or by optical fibre. If it goes by copper, copper is an electric conductor, so this is conducted by an electrical signal. So in this case, we would be having, this would be this is the electrical signal here. Then it's created into an EM wave, and that EM wave goes to the tower. Now that tower then, if your the receiving phone is not within a simple broadcast range, but it has to go a much farther distance, then this signal is sent to parts of the network where it is then transferred back into an electrical signal. And then it is sent to a receiving station that is close to the receiving phone. So remember, your phones constantly log in and log out of receiving stations. So whenever you go between 3 or sometimes just 2 if it's on a motorway, or even 1 if you're in the country, as you approach towers, your phone sends a signal to a tower to say, here you are. And as you move from tower to tower, the phone constantly gets handed from one tower to another as you, depending which was closer and which has a free frequency. This is called handoff. So your phone, the receiving phone and your phone know which towers they are close to. So this base station here will send an electrical signal to a tower which is already close to the other receiving phone that you want to send the message to. So that would be going back to the transfer. That would be the electrical signal here. EM wave is a radio broadcast to the tower. Then it goes back to electrical signal, then it's transferred by a copper cable to this tower down here. And then from that would be made into an EM wave. That EM wave is picked up by your phone, and your phone creates it back into an electrical signal. And you can split that, and then the rest of the way back to the ear. So that's that form. But if we do go by an optical fibre, colour, it's not really selecting. We go for optical fibre. Now that means that we need to create this signal here. The phone creates an a radio microwave to the tower. Then the tower then creates a light, because optical fibres broadcast light down the optical fibre. So we have to convert it from being a radio wave or microwave into a visible light photon, and then that is cablecast through the optical fibre down to the next receiving station. And then from there it is then put back as a radio microwave, and then from the radio microwave it goes back into the process. Okay. So there are normally, in our normal pattern, it's quite a straightforward way of dealing with the energy transfers and transforms, but we do have this one little complication which we also have to be able to deal with. So on this sheet, these boxes represent places that you can write in the energy transformation. Don't forget to also say how it is transformed. It doesn't just magically go from being an electrical signal into an EM. You say that it's done by the electronics of the phone, The microphone here is how you take sound and make it into a electrical signal. And just don't have to give too much detail, just tell me how it actually, what is the mechanism. This box here is for broadcast. This is EM wave to EM wave, and so on. There are some other things here if you want to take some notes, on brief notes or dot points of how the system actually works. Okay, so just make sure you download this or copy it into your books, and make sure you know all the energy transfers and transforms that happen within the mobile phone system. Thank you.